In this video, we will introduce a 3D wideband and high-selectivity amplifying frequency-selective surface based on slot line and microstrip line. First, we will introduce the structure of the AFSS. C1 is a bypass capacitor, which can filter out noise signals to provide a more stable DC voltage. L1 is used to isolate the RF signal and DC signal. C2 and C3 are DC blocking capacitors. On the top of the F4B substrate, a power amplifier and its bias network are embedded in the middle of the microstrip line. The type of power amplifier is TQP369180. Its operation band ranges from 1 GHz to 6 GHz, which covers the band of FSS forward. A pair of slot line resonators are etched on the back of the dielectric substrate. Metal vias are used to connect the slot lines and microstrip lines. Based on this design, the slot line resonator's presence will cause the plane wave to change into a guided wave. After that, the energy is coupled to the microstrip line where the power amplifier amplifies it. The energy is finally transferred from the microstrip line to the slot line by metal via. The slot line radiates the guided waves to free space after converting them into plane waves. Since the operating bandwidth of the amplifier is 1 to 6 GHz, which is greater than that of the AFSS, the out-of-band levels rise, which will lead to an increase in interference signals. To solve this problem, the following two steps were taken. 1. At high frequency, a transmission zero point is introduced. 2. The coupling effect between the microstrip line and the slot line resonator is appropriately reduced. To introduce a transmission zero point, a terminal short-circuit microstrip line is connected in parallel to the original microstrip line. As the length of the parallel microstrip line increases, a transmission zero appears at high frequencies. This greatly improves FSS selectivity and reduces out-of-band levels. However, some frequency bands outside the passband still rise because of the amplifier. To avoid this situation, the coupling between the microstrip line and the slot line resonator is appropriately reduced. Due to AFSS size limitations, lens antennas were used for testing. When the DC voltage is set to 0 volt, the amplifier is disconnected. AFSS has a high insertion loss due to its internal resistance. When the DC voltage is set to 1, the amplifier has a low gain, resulting in a passband with a 3 dB gain for the AFSS. When the DC voltage is set to 5 volts, the amplifier has a higher gain, resulting in a higher gain for the AFSS, which reaches 9.6 dB. For more details, please visit the published paper. Thanks for your watching. If you have any questions, welcome to contact us.